ये गाड़ी सबसे आगे
হুম।
এবার মিউট করো।
Hello everyone, welcome to this webinar. Uh, Today we are continuing from our last session. So those who are new to this one should know this. Previously we had one session on hybrid electric powertrain, and yeah, this is the part two. So previously we covered the very basic of hybrid electric powertrain. We knew the names of the components and where each one fits, what are the basic differences, right? And very small introduction about the battery system. Today we're going to dive a little bit deeper than that, but still it's a very uh, basic level. Yeah, so it's a very basic level thing, because you cannot cover the entire lithium ion battery design and all in just 1 hour. Actually MS on that too, on each segment, like for example on the analysis or on the design, everything. Okay, for those who are new to this session, so you must be wondering who is this guy. So yeah, this is me, Chayan. So I have around 6 years of experience in automotive R&D, and my experience is mostly concentrated in powertrain area. So I have worked on cars as well as on motorcycles. So you can find me on LinkedIn. Okay. So these are the topics that I'll cover in this class, and of course after that we'll have Q&A as usual. So first is our working principle of lithium-ion batteries. So we'll answer some key questions that people uh, seem to forget. Okay. So yeah, these important questions, and after that we are going to cover different types of cell. How do we classify them? Okay. And afterwards we are going to cover the construction of battery pack. Okay. How do we build a pack from different cells? Okay. And this one is mostly going to be an example basis scenario where I am going to take you through some contemporary vehicle. For example, today we are covering Tesla and Audi Q3. So how those are constructed. Okay. And yeah, next we are going to know the basics of battery thermal management system. Okay. See why battery thermal management system is important. If you see from a broader perspective, uh, from a OEM's perspective, there are three main work. First is the electricals. Okay. The second is structural. Third is thermal inside a battery. Okay. The other is chemical, and that is done by the supplier of the battery cell. Right. So these are our main works. Uh, okay. Yeah. Someone is not getting my voice. Please. Um, Can someone confirm if they can hear my voice?
Yes, sir. Yes, sir. Stay.
It's audible?
Yes, sir. Yes, sir.
Okay. Those who can't hear my voice, I am guessing you will have to start audio. It should be on the bottom left side of your screen, whether on phone or desktop. There is an option for join audio. Okay. Without that, you won't be able to speak or hear on any Zoom meeting. Okay. So yeah, let us start again. Battery thermal management system. So battery thermal management system is a very important thing, especially for mechanical engineers. So apart from this, we can the only thing we can do is structural. So as you can see, battery is an electrical component, but as you will come to know that majority of the work is done by mechanical engineers. Okay, because the electrical part is mostly very basic. Okay, or done by the suppliers. Okay. Here also we are going to go through an example based approach, and we are going to look at some real life scenarios. So yeah, And next, I'm going to show you what is battery management system and power electronics. Not very relevant for you. You just need to know what these are. At some point after completing the battery, mechanical engineers are the one who actually are responsible for cooling down these modules and also structural designs. But yeah, today we are covering battery. But talking about this, the sole purpose is that you should not confuse between battery management system and battery thermal management system. Okay. So before starting with batteries, let me take you through a quick timeline of battery development. Okay. Getting lots of messages. Okay, yeah. So a quick timeline of batteries. So as you can see, the lead acid cell, it was actually invented in 1859. So that is like 120 years from today, right? And this was like a marvel of technology for a long time. We are still using this battery, so it's hard to say whether lithium ion will last for that long or not. But yeah, uh, lead acid cell comparatively is incredibly complex, chemically speaking.
मुझे समझ आई हिंदी बोल रहा है खुश हो
After
गया
that came the zinc carbon cell. Okay, and zinc carbon cell, you know, your pencil battery.
मैं
And then in 1982 came the nickel metal hydride cell. This is the one that just give me a second. There is a, yeah, okay. So this is the one that started actually the EV revolution. Okay. Even before the yeah, even before any kind of lithium ion batteries. So early electric cars were nickel metal hydrides. And yeah, next is okay. Um,
आश्रम पंडितों को बड़ी यार क्लियरिटी देता है यार ये भी प्लेयर भी क्लियरिटी अच्छी है नेक्स्ट प्लेयर
may I request everyone to please mute your mic. Uh, okay, we're good to go. Um, Yeah, so the next one we have are the commercial lithium-ion battery. Though work was ongoing for quite some time, but the commercial battery launched only in 1985. So, okay, enough with the history. We have already covered all of this in our last lecture. So, directly moving on to the technicals. Okay. So, first, what we are going to cover is working principle of lithium-ion batteries. And the first and most important question is why lithium? Why not any other atom? Like there are like hundreds of other options, but the main reason behind picking lithium ion is its electrochemical potential. You see, some metals have the tendency to absorb electrons, some have the tendency to uh, let it go. Okay, so lithium is one of those metals which has the highest tendency of letting go any electron, like in our periodic table. Okay. So this is a lithium atom. Here you can see on this electrochemical potential chart, lithium is on top. It generates 3.04 volt. Okay. So here you can see this is a electron. This is a atom for lithium, and as you can see, if you are still in practice with chemistry, you would know this, right? So what we are doing is the orbital chart. So here we have different, like first one, this first orbit is our 1s orbit, right? So we have crossed it. S orbits hold 2 electrons, right? So now we have the second orbit. It's also a s orbit, right? But it only has 1 electron, but it wants to hold 2 electrons. So what this lithium ion will do, it always wants to eject this electron. Okay, it is happier and more stable when it has ejected the electron. Okay, So that's why lithium is highly reactive. Like you cannot keep it in open environment in air or in water also. Very reactive material. So yeah, that's lithium orbital equation. Okay. So lithium always wants to eject this one electron, and this is the natural state of lithium. By using this, we can create a battery. The only thing that we have to do is uh, position them properly. This is something that we are going to look into in our next slide. Okay. But before we can understand the working principle of the lithium ion battery, we have to understand first what are the like basic components inside of a cell, right? The lithium ion cell by principle are not any different from any other cell, right? So it has a anode, okay, and inside anode we have our lithium atoms uh, intercalated. Okay, intercalation is a process where one lithium atom is trapped between the layers of this oxide powder. Okay. So this can be an oxide of cobalt, manganese, magnesium, or mix of those aluminum, cobalt. Okay, but that oxide will have the ability to trap lithium atoms. Okay. And this intercalation was a very significant discovery in lithium ion battery pack. You guys would have heard that three people received Nobel Prize regarding lithium ion batteries. So three people did three different things. One person suggested to use the oxide. Okay. Another person figured out the process of intercalation. Another person figured out the process of producing the lithium ion in a commercially viable way. Okay, with a uh, graphite anode material, graphite cathode material. So, okay, yeah, there has been some like mistype. Okay, so here, if you see that, yeah, okay. So these are all the components in a lithium ion cell. As you can see, in the right hand side, we have our copper collector. Okay. In the left hand side, we have our aluminum collector. So here there is a typo mistake. Both are saying anode. Okay. But how do we figure out which one is actually the anode? Okay. So the rule is very simple. The copper collector will always be with the anode. Okay. And the aluminum collector will be with the cathode. So for battery, remember one thing: anode is negative side, cathode is positive side. Okay. So if I go back, so here we have the um, cathode this side, okay, and it has the lithium oxide. On the other side, we have the graphite anode, okay. In between them, we have a electrolyte. Okay. Now theoretically, these three things should serve as a battery. Okay. But still, in order to be practical, we still need few more components. For example, yeah, this neither graphite nor this oxide is very good at collecting electrons. So we have to add a collector. Okay. On the other end, we have to add a copper collector. Okay. There is also a very specific reason why one end we have aluminum collector and on the other hand we have copper collector. Okay, we are going to look into that shortly. Okay, so in between uh, both anode and cathode, we have our electrolyte. Okay, but you know electrolyte is a liquid, so it cannot prevent anode and cathode from touching. Okay, if anode and cathode touches, then there will be short circuit and subsequently overheating or fire. Okay. So in order to prevent that, we use a porous material, and it says it's called a separator. It's like a cloth. Okay. It is put in between this. So this prevents short circuit in normal working condition. Okay, and also a trick to remember which side is anode, which side is cathode is this. I call it CAC. Okay, so CAAC. As you can say, copper anode, aluminum cathode. Okay, so it's a quite a handy trick, but I am also going to tell you the scientific reason why copper is anode and aluminum is cathode. Okay, the reason is potential stability. Okay. I am not going to go too much in depth on this because it's a chemistry subject, but yeah, uh, the cathode always has a very high potential compared to the anode, which is at a very low potential. Okay. And aluminum is quite unstable at lower potential. Okay. uh, at this if we place aluminum on a lower potential in the presence of lithium, it will create continuously create alloys um, and then break it apart. Okay, so the aluminum will erode over time. Similar thing happens with copper, not exactly similar, but yeah, copper has what is called a dissolution. Okay, so both are bad. Okay, so copper should be placed where the voltage is high. The anode, the aluminum should be placed where the voltage is low. Okay, now the main components of a cell, we just saw what it theoretically is, but let's see what it actually is. Okay, we are going to look at a cylindrical type batteries. Okay, those who don't know about it, don't worry, we are going to cover it later in the course. But yeah, if you see this, one side is copper, one side is aluminum. Okay, and yeah, so seems like I don't have any control on this video, but yeah, as you can see, um, one side is copper, one side is aluminum, and then these are our collectors. Okay, then we have graphite on one side, we have our oxide on one side. Okay, in the middle we have a strainer. That strainer is coated with the electrolyte material. Okay, and then we then jam all of them together, and now we just roll them. Okay, now this is the battery that we see. Okay. This is the battery that you have on your laptop, probably many of your other devices. So something similar to that. Okay, and Tesla also uses this battery. They mostly use it because they were very early at that time. This was the battery that was readily available. Yeah. So as you saw, the actual battery um, layers, all of this in the this picture, it's highly exaggerated, but in practice, it's very thin, right? Very thin, and it is said the electrolyte is a liquid, but it's we cannot like feel the wetness. It's almost like dry. Okay. Yeah. So moving on, now we are going to discuss how does it work. So, mm, we have a model of a lithium ion battery. Okay, just very similar to what I showed earlier. Okay, I chose this one because this one has better representation visually. One thing to note that the side for cathode and anode has switched. Okay, uh, okay. So now we are going to go from right to left. So what happens is on the cathode side we have a oxide material, okay, which actually has the lithium atom in it. Okay, it's a suppose a lithium cobalt oxide, uh, something like that. Okay, it already has lithium in it. So in zero state charge condition, it's like this. All the lithiums are on this side. Okay, in this side there is nothing. There is only graphite. Okay. So, what is the purpose of graphite? So, graphite actually has a lots of space in between its parallel layers. As we know, graphite has like parallel layers, right? That's why we are using them. So, it has lots of space in between those parallel layers, and it can actually integrate lots of lithium atoms. Okay, and that's why we use graphites. Okay. So, uh, in order to charge this battery, right now there is no charge. What do we need to do? We need to apply potential here, right? Okay, so if we add a battery here, okay, or a charger here, okay, and at the positive terminal on this direction, okay, so what it will do is it will suck all the electrons, right? Will suck all the electrons from this lithium atom, because as we already discussed, lithium already wants to give up its electron from the outer orbit, right? So it will start sucking the electrons, okay, and it will take it and push it on the graphite structure. Okay, now the electrons can't go back through this way because this path has a higher voltage or potential, right? The electrons can't return from this way also because this electrolyte is actually impermeable for the um, electron, okay, just like semiconductor. This electrolyte does not allow electron to pass through. It only allows the lithium ions to pass. That too, uh, like now a question arises, like how come a liquid only allows a ion to pass through and not the electron? So what happens here? This specific kind of electrolyte, it is designed such way that when it touches an lithium atom, it will create these compounds, okay. Here in picture you can see this 4 5 flower like things. So what it is in center we have a lithium ion, and with that this the molecules on this electrolyte has created a compound, okay. Then it transports it on the other side because the other side is negative and the positive lithium anodes are actually attracted to the negative side, so lithium will travel to the other side, okay, and it will stay that way until we connect a load, okay. So here this picture, as you can say, this is a load, okay. They are showing it as a ammeter, so we are just measuring the current, but yeah, there is a load, okay. So when we connect the circuit or close the circuit, okay, what it will do is the electrons, the lithium want to go back to its original position, right? It wants to return to its original position. Okay, so the lithium will return to here through the electrolyte, directly through the electrolyte. The lithiums will come back, but the electron cannot come back this way, right? So now the electron will have to take the difficult road via the load, okay, and this way it is generating current. Right? Current is nothing but flow of electron. Okay, I'm guessing it is pretty simple, but yeah, still, if you have doubts, I'd suggest you look at some materials, online materials that is available YouTube or so. Very basic concept, okay. Because as I understand, we read the lead acid cell in class 7th or 8th standard. Lithium ion cell is much more simpler than lead acid cell. Okay, so it should be quite easy to understand. Exact same principle, not much different. Okay, so next what we are going to discuss is ACI and the first charging. ACI is the full form is where was it? Sorry, where was it? Yeah. So ACI and first charge. Yeah. So ACI, for full form of ACI is solid electrolyte interface. Solid electrolyte interface is a blessing is in disguise, and it's an accidental discovery. Okay. Uh, this actually reduces the capacity of your battery, but without ACI, we would not have been able to use lithium-ion battery. See what happens. For example, this is the same battery that we saw on the first slide. Here we have electrode. On the other side, we have graphite, right? So here we have our lithiums. Okay, but after charging, okay, so on the other side, on the graphite side, we have lithium as well as electrons, right? Now our electrolyte cannot touch electrons. Okay, if the electrons touch the electrolyte, then over time this electrolyte will degrade. Okay, and slowly it will stop functioning. Okay, so a battery capacity will go down, 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 and suddenly you have only 10 minutes of battery backup, something like this. So what happens when we do the first charge, the very first charge? Okay, the process that I just discussed, that was the first charging process, right? So when lithium ions passes through this electrolyte, it will create a layer of solid material. Okay, it's a complex material made out of this something taken from this electrolyte, something from the lithium, something from the graphite. The ACI formation, okay, takes up 5% of the total lithium that is present. Okay, so your phone had 100% capacity, phone battery. Now it only has 95% capacity left. But this ACI layer also provides the safety such that now electrons will never be able to touch the electrolyte. Okay, thus increasing the longevity of your battery. Okay, so yeah, this is our solid electrolyte interface. It occurs between the uh, graphite and that electrolyte. Okay, there is another thing called dendrite. Lots of messages are there. Okay, okay. So dendrite formation and safety concerns. Now there are ACI was a good thing. Okay, dendrite is not a good thing. Okay, it's bad in every way. Um See, this is a battery schematic similar to what we just saw. Okay, so the bottom side is anode, it's lithium. The top side is cathode, it's graphite. Right. So in between them is a separator and a electrolyte. So what's happening once we use and reuse the battery, a uh, dendrite like structure forms. Okay, structure like this are called dendrite. Okay, it's like a fungus. Okay, it expands like a fungus. And what happens, this thing keeps like keep rising and rising. Okay, we are talking in nanometer scale, but this thing uh, keeps rising, and after a certain period of time it will protrude the separator. Okay, once it goes through the separator, it will touch cathode, and the result can be catastrophic. Okay, it will be a short circuit immediately, and immediately there can be fire. So very real fire hazard is there. Okay. So that's why everyone is so excited about the solid state batteries. Some of you may have heard, because this electrolyte that we use for lithium ion batteries, there are many different electrolytes. All of them are combustible. Okay, so if there is a spark, there is a fire, it will catch fire. Sometimes the batteries explode, sometimes it just burns, but there is a high risk of fire. So preventing the dendrite is a utmost priority. Okay, some research are being done on this. Some companies are actually like actively working on methods to solve this. Okay, and bottom side you can see a real picture of a dendrite. Okay, in real life it actually looks like this, not exactly like this. Also, this dendrite is kind of in early stage. Okay, so it will increase. Also, to know another thing, dendrite will always form on the anode. It cannot form on the cathode side. Now, why dendrite form is a difficult question, because the research on this is still ongoing. There are different hypotheses. Okay, but yeah, one is like uh, one simple reason that people, it's a hypothesis, it's not a proven reason. Okay, but they say that when the lithium ion flows towards the electrode, okay, uh, the dendrite mostly follows this flow trajectory. Okay, so due to that pull, some lithium oxide is, comes out, and every time little by little it increases. Okay. But in order to prevent dendrite, we have to like stop its progress on vertical direction. So what they're doing is like using some kind of film barrier. For example, there is some barrier. Most of our devices, for example, I don't think my phone or our car batteries even have this. This is kind of research level technology. But yeah, there can be a barrier which prevents it from spreading. See, here both of these are different barriers. Okay, but on the right hand side it's a normal barrier, on the left hand side is a piezoelectric barrier. As you can see, this one also stopped the growth somewhat, but this one like stopped it a lot. Okay, so these things can really help. This battery, if it was a normal battery, then it would have been gone by now. Okay, so yeah, now we are going to cell types. Okay, time is kind of limited here. I had a lot of things in mind. Will not try to rush everything. If there is some things left here, we will just continue on the next class. Okay, so the cell types, cell classification by chemistry and cell classification by form factor. Okay, uh, I won't explain it. You'll know what I'm talking about right now. Okay? So there can be different types of lithium ion cells. Okay, based upon the chemistry of the uh, cathode. Okay, where was I? Yeah, sorry, the chemistry of the anode. Okay, cathode is never changing most of the time because we have been using graphite cathode for a very long time. Okay, so for all of this, keep in mind the cathode is same, only anode is changing. Okay, so the first is this LCO or lithium cobalt oxide. All of these have lithium at start, so I just removed the lithium part. So LCO is lithium cobalt oxide. It was the first popular lithium ion battery, still used in lots of mobile phones and things. Okay, I think most of the mobile phones are running on this lithium cobalt oxide. We are not going to discuss all kinds of cell chemistry. We are only going to discuss those which are relevant for automotive application. Okay. So next we have LPF, so lithium iron phosphate. It's lower capacity, little bit safer. Okay, it doesn't overheat or catch fire so easily. Next we have LMO, lithium manganese spinel or manganese oxide. Okay, so it's an alternative to cobalt oxide, but yeah, it doesn't have quite as much uh, like power density or specific energy. Okay, it's not as powerful as the cobalt oxide, but it's very cheap because manganese is readily available. Then we have our NCA battery, nickel cobalt aluminum oxide. Okay, this kind of battery is used in cars. Okay, and as of my knowledge, only one company still uses this. huh, that is Tesla. They are kind of still hold up on the old things. Everyone has moved on. So other one is NMC battery. So NMC battery is comparatively newer. Okay, and it's also cheaper, though the cost of the lithium ion battery is very difficult to guess because the raw material prices are like nothing like normal iron or aluminum price, which is steady. These are like since 2017 to 2018, cobalt price raised by 100%. So previously it was 40 or 45, then it suddenly become 85 or something. So price is a debatable point. Okay, the last one is titanium oxide, titanate oxide. Okay, it's very expensive. We can not use it on cars. Okay, The titanate oxide, the special thing about this is the only battery that is actually changing the cathode. Okay, all the other batteries that are changing the anode. Okay, on cathode side everyone has graphite. Okay, for the titanate oxide we are changing the graphite with titanate oxide. On the cathode side we can use any of this like cobalt oxide or a NCA or NMC. Okay, anything, but on the cathode side we are changing. So the titanic oxide is very expensive because it's very difficult to formulate. Okay. And this the facility that this LTO provide is fast charging. Okay, nowadays lots of phones are having fast charging, so many of them are having this LTO type thing. There are some other things like gallium type electrode or like collector and all those things, but yeah, I'm not very much aware about those. Okay, so these are the two batteries NCA and NMC that are relevant for automotive application at least these days. Okay. So it's a spider chart. Okay, some of you, there are lots of students here, so I'm just going to tell what a spider chart is in a very real quick. So you measure from center to the outside. Okay, how much is the distance? Okay, so for example the specific power, it's here. Okay, and the specific energy it's here. So from center this is larger, that means this specific energy value is higher. Okay, the spider chart, it can only be used if we want to overlap uh, two things. Okay, two materials, two product, anything, uh, to compare them. Okay, so only one radial direction is compared to the exact same other radial uh, direction, but you cannot compare between the specific energy and the specific power. Okay, so this spider curve is for NMC battery. Okay, there are different parameters. Okay, we'll go through them. Now we have the NCA battery. Okay, so NCA battery, the Tesla battery, NMC battery, everyone else's battery. Okay, from BMW, Volkswagen, so everybody uses the NMC battery. Okay, so as you can see, NMC battery have better safety. Okay, it's highlighted in green. Okay. But the NCA battery has better specific energy. That means it has more range. Okay, specific energy means energy stored per unit of weight. So it can store more energy. So it has more range. Right. The other things are quite similar. The specific power, performance, lifespan are similar. The cost, as I said, is very controversial. So I did not measure that. Okay. But yeah, these are the basic difference. The NMC has is more safe, and the NCA is like having more range. Okay, so one thing reason why Tesla uses the NCA batteries is because they have a lot more experience in developing battery packs. Okay, and they have gained a valuable experience on softwares. Okay, so for the battery management system, the computer system that actually runs the battery. Okay. Their softwares are very intelligent in better using the battery, so they have less chance of fire or overheating with a even a bad battery. Okay, not bad, but comparatively unsafe battery. Okay, so this was a basic classification. So these two are the things that you need to know: NMC and NCA. One of these are going to be in your car. So cell classification by form factor. There are batteries in different shapes and sizes. Okay, different companies also use different type of battery. So first and very famous. Okay, uh, okay. So only three types of shapes and size are used in cars. There are others shapes and size, but those are in other applications. Like in watch, you have seen a battery that is thin like a coin. That's also a lithium-ion battery, but we are not going to talk about that. So first one is the lithium ion battery. First one is the cylindrical battery. It just looks like a pencil battery. If you have an old laptop, if you open up your battery, you will find this kind of round battery inside your laptop. Okay, and yes, so the cylindrical battery, Tesla is the user of the cylindrical battery. Nobody else uses it because in 2003 when they started production, This was kind of the only good battery available. Others was pouch like batteries. Those were very bad in quality, and also they did not choose this battery. You see, initially when Tesla started, there was a company called AC Propulsion. It was the name of the company. They actually designed and manufactured the entire powertrain for the first roadster car. So they picked it. They picked this battery, and they just went on with it. Still, okay. Now we have the prismatic battery. Nowadays, almost every good car manufacturer, every luxury car, everyone is using this prismatic batteries. Okay, I have seen it in use like many times. Okay. Everyone uses this kind of battery. Very comparatively cheaper, comparatively easier to use these batteries. Nowadays, we have better tool for heat calculation than all. So overheating also, those are also like less of a concern comparatively. Okay. And at the end, we have the pouch battery, the poor man's battery. This one is used in Nissan Leaf and Chevy Volt in this kind of cars. This kind of batteries, as you know, similar to your mobile phone battery, has difficulty in dissipating heat. Think of it. It's a pouch, maybe 5 millimeter thick or 6 millimeter thick. Okay. So both side, if you use a flat plate to eject heat from both sides, okay. So what is happening is both side is ejecting heat, but the layers, the lithium ion battery thing is a layer, as we saw. It's a spiral for the cylindrical. Same for this, all of this other, the prismatic and this pouch type. So the central layers are very difficult to cool down. Okay. Over time, pouch type batteries will inflate. Okay. Or they will lose their capacity. Of course, it can be comparatively mitigated by using proper cooling methods, but yeah, it can never be as good as a cylindrical or prismatic batteries. Then yeah, we cell form factor. Okay, so as you were seeing, the inside of these batteries, these are the three batteries that we just discussed. All of these have essentially the same component, just packaged in a different way. Okay, neither electrically nor chemically there is any difference, just packaging is different. Okay. Okay, so our we came to the next module is the battery pack construction. Okay, so some of you may not know the concept for cell module and pack, so we are going to touch on that, and then components of a typical battery pack. Okay. So for a typical, we are going to pick up some contemporary example. For example, the Tesla Model 3, the I think 2018 version. Okay, that's a pretty recent car, right? Mm, so yeah, this is the concept of a cell module and pack. So this lone cell, it's called cell. Okay, the single battery. Actually, the term that we use, we call it's a pencil battery, right? But the term is wrong. Okay, uh, battery is a term that is used to define a collective collection of things. Okay, the lead acid cell, the lead acid battery is a battery because it has multiple cells. Okay, sometimes it's a 16 cell battery, sometimes it's a 12 cell battery. Right, for car it's I think 6 or 8. So it has multiple cells. That's why it's called battery. Battery is a connection of multiple cells. Okay, but we are not going to go too deep on this. Everybody says this these days. So single cell, a collection of some cells are a module. Okay, ignore this 8 cells. Okay, it doesn't have to be 8, it can be lot more, like hundreds, many hundreds. Okay, and then a collection of these modules are called a battery pack, and a battery pack is what we see as a whole battery in a car, right? So these batteries will be um, connected uh, depending upon the voltage and current requirement. Okay, they will be connected in either series or parallel. Okay, so we are going to look a little bit into that also, but yeah, let's just first see the components. Okay, so here um, you see we have an exploded view of a battery. So intentionally I pick a small battery. This is the battery from a hybrid electric car. This is not a like pure electric car. So that's why the battery is small. As you can see, there are only 4 modules on this battery. Okay, so quite an simpler, comparatively simpler subject to study. Right. So let us look at this particular module. Right. How does it look? So as you see, this is the module, and in this module, okay, from top it looks like this, from bottom it looks like this. Okay, there are this 1, 2, 3, 4, 5, 6, maybe 8, 9, or 10 cells are there. So these are all individual cells. Let's take a look at one cell. Okay, so this is one individual cell. So as you can tell by looking that this is a prismatic cell, no doubt about it, right? And now, what's inside of this cell? Okay, outside we can see that this looks like a metal casing, right? Most of the time it's a aluminum casing. Okay, so yeah, as you can see, on the outermost side we have a thermoplastic film. So this film is giving it this greenish uh, appearance. Okay, and inside of this is this aluminum can. So this can, okay, and inside of this mylar, it's basically a insulating layer. Okay, and after the inside of this we have our jelly roll. Okay. Previously, last time I spoke about the concept of jelly roll. Jelly roll is nothing but uh, rolling all the electrodes. Okay, as we saw on the video or the animation that we saw earlier, there the pencil like battery is made by rolling everything. So that is the process that's called jelly roll. Okay, so here it's rolled, but not like cylindrically, but it's like rolled, then it's like made flat. Okay, there can be multiple rolls actually inside of one battery. Okay, and now we have these things. Okay, these are our tabs. Okay, so tabs are the things that connects with the connector. Okay, in the battery initially we saw uh, inside the battery we saw there was two connector. One side was aluminum connector, one side was copper connector. We also learned like which one should be on which side, the aluminum copper connector. But yes, this tabs will connect to the connectors and uh, eventually supply electricity to the outside world. Okay, so this is all that's inside of a battery. So we are right now not considering other components, for example electronics. Okay, these electrical connections. Okay. There are cooling arrangements or the thermal management arrangements. Okay, all of these things are there, but just considering the basic battery. Okay, so that car was called A3 I think, and this one is A-tron. Okay, so this battery, if you see, mm, if you look at it, okay, so there are different layers. This is an exploded view of a battery. So as you can see, this is a tub, right? This is a tub or tray. This is where everything will sit on, right? For this particular battery, and consider for this particular battery only, okay, there is a frame, okay, on the outside. One thing to note that is battery is still comparatively new, so lot many of the things are not yet standardized, and there are lots of scope of innovation. So uh, every year new kind of battery structural design is coming up, one better than the previous one. Okay. So yeah, this battery has a frame around it. What it does is eliminates the need for a BIW reinforcement in this area. The battery itself is now part of the body. Okay, it is supporting the body via this frame. As you can see, this frame has a very strong honeycomb type structure. Right? Okay, so outside of this, outside of this tray, we have our cooling plates. Okay, as you can see, this is saying cooling system. So from one side we are entering cold water from maybe from here and here, and it's going through like this, like this, like this. Okay, in the process it's cooling down the batteries, okay, and it's exiting from the other side. Okay, then we take it to the radiator and do it again. We'll look into it in more detail in this lecture itself. Okay. Okay. Now, one thing I want to tell is before continuing, please once you finish this webinar, okay, please you would have received a mail for a feedback. Please go to that link and fill your feedback. Okay? Your feedback is very important. Based on your feedback, we chose this topic. Based on your feedback, we'll choose our next topics. Okay. Also, it is a way for us to track the attendance. Those who are new should those who are new for this is for them. So we provide the certificate of participation or attendance upon completing 4 lectures, because see, we cannot just provide you a certification for attending just a 1 hour lecture. Okay, so once you complete 4 lectures and fill the feedback sheet, you'll get a participant certificate of participation. Okay, some universities are requiring it, that's why. And yeah, also like it's a good place for your voice to be heard, anything that you want. Okay, so yeah, so on the outside we have our cooling plates, and outside of that there is always a protection, because the road will have debris, right, rocks and all, so this thing protects the cooling plate. On the inside, this particular design has a like crash structure. Okay, it is also called a reinforcement structure. Okay, so this cross shaped design, it actually provides strength for both frontal collision and the sidewise collision, because it has both longitudinal and cross members. It also actually acts as a housing for the batteries, right? These are our batteries. It will actually go sit on top of it, right? So these will slide right in these slots, all of these batteries. Here you can see lots of wiring and connections. Some of these connections are very strong copper pipes, thick copper pieces. Okay, these are called bus bars, connecting each and every battery. Similar thing is visible on a lead acid batteries also. So this is how we do the series and parallel connectioning. Okay. And of course, we have our internal wiring for battery management system. Battery management system, the job of battery management system is to prevent overheating and run the battery in an optimum condition. Usually over this we will have a layer of like insulating materials. For example, this data is published by Audi themselves. Okay, so they maybe don't want to publish everything. Okay, so bear in mind lots of things are missing here. Okay, but yeah, there will always be some kind of insulation. Maybe for the lower side there is no insulation, because we need to uh, transfer heat on the lower side. But on the lower side, instead of an insulation, there will be a thermal paste. Okay, same paste. If you have ever repaired your computer for overheating, the mechanic actually applies a paste. Okay, metallic paste. So this thermal paste actually improves conductivity between two surfaces. So that is actually applied below the batteries. Okay, so on top side, most likely there will be a insulating material that is also fireproof. And yeah, so on top of it we have a cover. Okay, so everything is made out of aluminum for this case, hence the cover is also aluminum. Okay, so when it closes it should be like leak proof. Okay, for this particular battery there is a separate battery junction box. Okay, not all of the batteries have it. Actually, I never have seen it any 3 or 4 batteries that I have seen till now. Okay, on the rear side we have the battery management system here. Okay. Normally we have the battery management system here. For this one we have another 3 cells. Okay, okay, so they are actually calling the battery management system the junction box. Okay, it's nothing but the battery management system. Okay. And this thing, just ignore it. Most of the batteries doesn't have this extra bump for extra batteries. They must have done something wrong during the design. That's why they have to like add some other extra batteries to compensate or something like that. Sometimes, sometimes suppliers tell us that, yeah, we'll give you battery of this much capacity, and then they fail to deliver on that. Okay, and that's when maybe they saw that, yeah, we are like 15% low on power. Okay, let's add two more batteries. Guessing just. Okay, so yeah, another Audi battery. Similar thing, just in little bit more detail. Okay, here as you can see, as I was saying, there is a layer of insulation. As you can see, there is always insulations. Okay, then there are these cooling systems. So these are plates type cooling. This is a flat plate. Okay, flat plate which has cooling channels built into it. Something similar to those that you see on a transformer. Okay, these are flat plates. Okay, these are different modules, and in between the modules there are these cooling panels. Okay, this kind of design is not very suitable for high intense or intense applications. Okay, this is like only for mild load, because it will heat up. Okay, and the cooling method doesn't seem very efficient. Also, it's very cost efficient. It's not very functionally efficient in my opinion. Okay. But yeah, maybe they don't need high performance for this particular battery because it's going on a PHEV, or maybe a milder hybrid, so it only assists. Okay. Okay, yeah. So Anirudh, please, are you noting down the questions? Please note down the questions. So we'll answer all the questions during the Q&A. Yeah. So the next thing is battery thermal management system. This is something where I wanted to spend some time. I'm hoping you are not in a hurry because it will take another 15 minutes at least. And this is the most important part inside the battery for a mechanical engineer. Others were just like warm up. Okay. So as the powertrain engineer or as the mechanical CA engineer, this will be your job. The thermal management system. Why do we call it the thermal management system? Why don't we call it the cooling system, like the engine, right? That's because batteries need cooling, but batteries also need heating also in cold environments. Batteries are like humans. Okay, you cannot keep them very cold or too hot. Okay? Anywhere where you will feel uncomfortable, no, but you should not keep your battery. The optimum range for a battery can survive from like 40 to minus 40 degrees centigrade, but it will degrade heavily. Okay, the ideal range is from 20 to 40 degrees centigrade. Okay, okay, but automobile batteries which have the requirement to last 10 years or so, they have a even more stringent requirement. We try to keep the battery from 35 to 40 degrees centigrade. Never in any case we don't let it drop below 30 degrees centigrade. Your mobile battery, as you know, its temperature rises and drops with your environmental temperature and also with the heating of the phone and so on. So yeah, 35 to 40 is a desirable temperature for automobile batteries, and so the battery lives in a air conditioned house. So we have to keep it cool, keep it hot. So the necessity of BTMS. Okay. First of all, what is the requirement? Okay. So what the BTMS does is monitor and optimize the thermal status of batteries. Okay. What it basically means is it controls cooling, it controls heating. Okay. It provides insulation, it provides ventilation. Okay. Now you ask, why is ventilation important for battery? So ventilation is like just in case if toxic gases uh, starts build up inside the battery, there should be a place for them to get out, right? Otherwise, the gases will eventually uh, blast the battery, right? It will be violent. Okay, insulation is also very important, especially in cold countries. Okay, in very hot countries also, like you just stop your car over a tarmac. Okay, hot beach road. Okay, uh, instantly it soaks up lots of heat from the road itself. Okay, then having an insulation mechanism prevents it, right? And in colder climate it's very crucial. So you can uh, heat up the battery little bit, like not while charging but while discharging or running condition. Little bit heat is acceptable, but if the cold is high then you will definitely lose your battery capacity over time. Okay. Yeah. So uh, here you can see there is a temperature range shown on the curve. We have already mostly described it, but yeah, as you can see, the how much battery, how much power a battery is able to provide at different temperature range. So horizontal direction, temperature, vertical direction, percentage of its actual capacity. Okay. So as you can see, from 20 to 40%. 20 to 40 degree centigrade, it can provide like 100 or more than 100% of the power. So the discharge rate is higher than its normal rated discharge rate. Okay. But after 40 it like drops drastically. Okay. Similarly, after 20 also slowly drops, and on the negative side it also has a drastical drop zone. Okay. So yeah, what happens if you run the battery in hot condition? What happens if you run the battery in cold condition? Okay. So in hot condition, okay, you know the relation of what is it called? Yeah, resistance and heat. Okay, resistance creates or generates heat, right? And also heat also increases resistance. Okay, or what was it? Joule's law, I R square H or something. So the more temperature you give to the battery, okay, it will increase the resistance. Okay, the increased internal resistance will create more heat. So the cycle goes on. It's a snowball effect. Okay, this situation is called thermal runaway. When a thermal runaway is achieved, okay, and you don't stop using the battery, this battery will surely like catch fire or explode. Okay, because it will reach temperature upwards of 250 degree centigrade. If the battery is very strong and not exploding, then it might even reach temperature of 400 degrees centigrade. Okay. Another reason for thermal runaway can be short circuit. Okay. But we are not discussing this right now. We are discussing high temperature. Okay. So yeah, on high temperature scenario is bad for our battery because it will also accelerate the dendrite formation process. Earlier we saw the dendrites. Okay, so more dendrites are formed during the high temperature scenario. Most dangerously, the electrolyte becomes volatile. It loses its operational efficiency. And in lower temperature, charging and discharging reduces your battery backup, the capacity, the state of charge, if you can use it technical term. The technical term for the health of your battery is the state of health. Okay. This term specifies like what is the current condition of your battery, how many percentage of the original capacity. Okay. So the next one is the classification of pack by thermal management methods. Okay. Okay, yeah. Let me mute the person, whoever it is. Mute. Okay, now everyone is muted. Should be clear. Classification of pack by thermal management methods. Mm, So there are different types of cooling. So one is active cooling, one is passive cooling for batteries. Okay, what is active cooling? So the term active cooling means controlled cooling. Okay, where you can like readily control the outcome, and you can also like achieve uh, um, like fluctuation according to the fluctuation of the battery or the power demand. You can change the um, cooling capacity. Okay, so the passive cooling is there are several types of passive cooling. Okay. So take these three. One is phase change material. The PCM is a different thing on itself, but simply put, it's related to the latent heat. Any material, if we if um, changes state, okay, it becomes from solid to liquid or liquid to solid, it will absorb some latent heat or release some latent heat, right, without changing the temperature. That is the principle that is being used. So instead of adding a heat exchanger, what we are doing, adding a material. So when the temperature of the battery increases, the material starts to melt. While the material is melting, it is absorbing all the heat as latent heat, and it's not letting the battery temperature go beyond that range. Okay. So this kind of materials is good for small fluctuations, but slow also, because this is a slow process. Okay, that's why it's not very popular. Next one is the natural air cooling. Natural air cooling is like simply a air cooled battery. There is not even a fan. Okay, when you drive the car, air enters through some vents. Okay, and air exits on the other side, and your battery is cool. Okay. As you can note that there is no control on like um, how much to cool or not. Entirely depends upon your speed, right? Then there is the forced air cooling. Okay, without air conditioning. Okay, it is also considered a passive cooling because it gives some control, but not actually sufficient to like control everything. Okay. Mm. Now we come to the active cooling. Okay, on the active cooling, first thing that we see is forced air cooling with AC. Okay, so with the addition of the air conditioning, now the forced air cooling is effective. Okay, and it can like work as an active system to like uh, work on real time to improve or reduce load. Then we have our liquid cooling. Okay, there are many varieties of liquid cooling systems, but two main types are, one is direct, one is indirect. Okay, some of these names will be like not this classification thing. Okay, there are some debates on this, so this is something that I made based upon my years of experience. Okay, somewhat might do it slightly differently or add or remove a few things, but yeah, mostly it's like this. So the first one is direct. Okay, the second one is indirect. So as you should know that the direct kind of cooling is very rare. It is not used in automobile, not at all. Okay, believe me, we have tried to use it. This direct cooling, there was a lot of hype on it, but yeah, it did not work out. The direct cooling means the coolant is a oil-like substance. It's a dielectric material which doesn't conduct electricity. So there is no risk of short circuit. So you just submerge your battery on that liquid. Okay. This kind of cooling process is very popular for servers. Okay. The data servers. Okay. Data servers are using this kind of cooling. They call it immersion cooling. We call it server cooling. Okay, because it came from the servers, the technology. On the indirect cooling, okay, we can use any kind of electrolyte, any kind of coolant. Okay, previously we were limited by only those coolants which are uh, not conductive, like which are dielectric, which are not corrosive, not flammable, and all kinds of things, because they come in contact with electric components all the time. So there was lots of criteria to meet. But now we can just use our plain good old water. So in car, we never use only water. We use a mixture of glycol and water. Usually it's a 50-50 mixture. Okay, 50% glycol, 50% water. Glycol is the thing that usually looks green or reddish in color. It's also called antifreeze. Don't eat it. It's very poisonous. Okay. And don't spill it on your car. Otherwise, and it will, like, ants love this because this thing is sweet. So, bit of advice. So yeah, water glycol based coolant, but this one has a chiller. Okay. A chiller is a component that actually connects the air conditioning system with a water based cooling system. Okay. Suppose you have cooled down the water using the radiator. Radiator can never make the water cooler than the environment, right? But the chiller can. Inside the chiller, from one side, our refrigerant enters, which is at very low temperature. On the other side, our water enters. Okay. And when they passes each other inside the heat exchanger, they don't mix actually. So the water becomes very cold. Okay. Yeah. Then we have others like water based water glycol based, but without a chiller. Okay. And next, among the indirect heatings, we have another type in which the cabin heating is done through coolant. Okay. And the next one, the cabin heating is done through electric heater or heat pump. Before electric cars, we never had to think about the energy for cabin heating, because earlier we used to have a heater pipe coming out of the engine. Okay, it took some of the hot coolant from the engine and, like, used it to cool down or heat up the cabin. Okay. But now we don't have any kind of engine, so we have only two options. One is to take a connection from either the battery or the motor. Okay. Or the other one is to, like, use a separate electric heater or heat pump. Okay. So electric heater is kind of inefficient comparatively, but they are very lightweight, and heat pump is comparatively efficient. Okay. Yeah. That's about on the type of cooling methods. So whatever we are going to do, we are going to focus on these two kinds of cooling methods: water based with chiller, water based without chiller. Okay, every single of the car manufacturers uses any one of this. Okay, as I said, the immersion cooling still doesn't exist for automobile. The air cooling is only for the cheapest of the cars. That is, for electric, it is the Nissan Leaf. Okay. So for a very cheap car, the this thing works. For a very small battery, for a very small motor, for a car that is never going to push. Okay, so everyone else is using the liquid based cooling, the water based cooling. Okay, so there are different kinds of heat collector. Like these are actually pipes. Okay, that are collecting heat. For example, this one is called a serpentine connector. Okay, because it's like a snake. No, you know, on the Harry Potter there was a department. Okay, so yeah, it's like this. This is seen in the Tesla batteries. Okay, any kind of anyone who trying to use this cylindrical cell will have to use something like this. There can also be an option to use something like this. The plate that the guy is holding. Okay, you can just put all of these batteries over this plate, right? And as you can see, there are two uh, entries on two sides. So one is a inlet, one is outlet. If you closely follow the path, you will see that water enters here. It follows the entire path of the plate. Okay, goes through this route. Okay, and it will then eventually exit on the other side. Right. So has good effectiveness in terms of cooling. It's also very cost effective. And there is another type of cooling. It's a plate type of cooling, as I was saying earlier. For the pouch type of uh, cells, this kind of cooling is very suitable. Also for the prismatic cells, as I was saying, the Audi battery, I was saying the cooling system doesn't look uh, very, like, effective. So this one also had, that one also had this kind of plate. Okay, some variation of this plate. Okay. We have similar kind of plate in our transformers also. Now, coming to the moment of truth. So this the example of a modern battery thermal management system. Okay, and we are looking at the most modern car, the Tesla Model 3 2018 version. Okay. So let's look at it. This is our car, okay, and this is our battery. These are our charging cable connections, motors, okay, controllers, and all these things. But yeah, as you can see, this is our battery. Okay, this one. So in this battery, the what are the specs? This car has 21,700 cells. 21,700 seems a bit high, but yeah, uh, yeah, it should be like that. Okay, and then this pack is like 75 kilowatt hour. Mm, okay, then we have this kilowatt hours, and lastly we have four different modules. Okay, as I was saying earlier, that the module doesn't need to be 8 cells. Okay, here we have like four very large modules. Okay, each of them are having many thousands of batteries. I think there is by mistake there is 10 extra. Oh, sorry, my mistake. So this one is saying 2170 cylindrical cell. So this is the designation of the cell. Okay, so 21 is the diameter, 70 is the height. Okay, total number of cell is 4416. The previous one I think had 3000 cells, that I remember. Okay, so yeah, and also it says the 25S 64P. What does it mean? Okay, it basically means the orientation or the connection, electrical connection of the battery. 25S means 25 in series, 46 in parallel. Okay, and from this you can literally calculate the power, voltage, everything. Okay, if you know the power and voltage for one single cell. Okay, so yeah, that is the battery, 2170 battery. Okay. And next we have our all four modules. Okay, so how does the coolant flow occurs? For this case, the coolant will go through the plate. Okay, as we were saying, either the bottom or the top plate. Okay, so coolant is entering from front side, it's exiting from the rear side, and it is again going to the radiator. If you look at the circuit, then this is the circuit. Okay, so yeah, these things can be discussed in a lot more detail, but the only thing that I want to point out right now is the chiller. Okay, I was talking about the chiller. So as you can see, this is the chiller. Okay, so chiller is connected to the battery here. Okay, and this green this blue colored circuit, okay, it's the AC circuit. Okay, so cold refrigerants going through this. And this green circuit, it's our coolant circuit. Okay, so yeah, coolant is going out. Okay, being cooled down in the radiator, and then it's again like coming back through the chiller. So it's going out from this way, getting cooled in the radiator, it's coming back through the chiller. Okay, there is sometime a bypass connection also to bypass the chiller when it is not required. Okay, because this is the common air conditioning system that is also providing comfort to the passengers, so you cannot turn off this one, but you can just bypass the cooler connection. Okay. Mhm. Similar BTMS system for the Audi battery that we were just saying. This one is only in more detail. Okay, you guys can take a look at it on the presentation when you download it. And this is the circuit for that Audi model. Note this thing, that this one also has a chiller. Okay, This one also has a chiller battery, so it also has a this AC circuit and a coolant circuit. Okay, so when the demand is high, when the battery is under lots of stress, generating lots of heat, in this those case we can yeah use the chiller or the AC. So we have reached almost to the end. So just to finish it, I just want to show you what is BMS. BMS was already mentioned several times in this class, but finally, BMS is the electronic system that actually controls the batteries. Okay, so that every battery is evenly charged or discharged, or every battery is evenly uh, the temperature is similar. Okay, it should not happen that as a overall battery pack everything is okay, but one single cell is heating up. It's very common. Okay, so the very advanced intelligent electronic system is very important. Otherwise there will be like no car battery will last 10 years. Okay. Similar thing also goes on for your laptop also. Inside your laptop there is a BMS. When there is multiple cells, there is a BMS. Okay. And now comes the power electronics. Power electronics are the components which actually helps a electric car runs. Okay, so these are the components that helps the powertrain work. Okay, for example, for battery is the battery management system. There is a DC to DC converter. Okay, which actually changes the voltage. Okay, there is a there are controllers. Okay, there are OBC or onboard charger. Okay, motor control unit. Okay, all of this thing. um, Also inverter. Okay, there is sometimes AC to DC converter if the car has AC charging capability. Okay, so all of these electronics are called power electronics collectively. Why it is important for us? Because we are responsible for um, designing the cooling arrangement for the power electronics. These parts are very heavily stressed. They generate lot of heat. Even this inverter and controllers, all of they need water cooling most of the time. So we need to provide them. Okay. So yeah, these are the references for this webinar. So the last thing that I would like to say is don't spend your time on YouTube trying to learn things. Spend your first 2 3 hours on YouTube. Okay, YouTube is only good for that much learning. After that you have to actually have to read some actual research paper, because the things on YouTube are on a very basic ground level, sometimes outright wrong. Okay, so do read some research papers. Okay, try to read some thesis. Okay, the advantage of thesis over of a thesis over a research paper is that thesis starts from a very basic level. Okay, it will explain everything before actually going to the research project. So first 3 4 chapter of any thesis that is regarding lithium ion batteries, okay, you will get a lot of good knowledge. Okay, so research paper and thesis are a good uh, place to shop for knowledge. Okay, so yeah, thanks a lot for joining. So please fill the feedback form. Next week we will be um, conducting as per your feedback. If we don't if we have kind of a tie situation, then of course we will continue pick up from this electric vehicle thing. Okay, of course in order to go more advanced into the electrical things, we'll have to invite someone, but for the thermal things that would be me. Okay, also a lot of you have asked for engine auxiliary system related classes. So yeah, that one is also coming up. So yeah, there are questions now. Mm, I almost forgot. I was about to end this thing. Okay, so can anybody shoot me with the questions one by one? Anirudh, if you have the questions listed, or Dhruva sir. Hello. Wow, it's so pin drop silence. I'm wondering whether my mic is working. Can somebody speak just to test?
Yes, you are audible, Chan.
Okay, yeah, I can also hear you. So there were some questions as I remember on the chat. Lots of messages are there, kind of impossible for me to find the questions. Wow, there should be at least a few hundred messages. Okay, here I can see from if I start from bottom, what is life of battery depends upon. Okay, so the life of battery depends upon a lot of uh, things. Okay, all the things that we discussed earlier. For example, if you use your battery, how much state of charge is remaining on the battery? See, uh, when the battery is being charged or discharged, it's a physical movement of lithium atoms, right? So when you discharge your battery, okay, um, like entirely discharge your battery, some of the lithium atoms won't be able to come back to the other side on the next cycle. Okay, and that is a side effect. We should never like discharge our battery, any battery, mobile battery or car battery. Lots of automobile batteries are have software lock on how much of it you can use. You should never run it till dead. It is recommended to use a battery will give the longest life if you use a battery constantly at 80% charge. Okay, then it will give the longest life, but for a normal usage 20 to 80%. Okay, same goes for automobiles also. The new car that Porsche launched, it has actually locked the bottom and top 15% for this purpose, and the range automatically got reduced for that car. But yeah, there are other things like temperature, the thermal management, very important. The um, battery management, like electronically how good the battery is being managed. So all of these things add up. Okay, and at the end of the day, the another most important thing is the actual chemistry of the battery, right? Some batteries last longer, some doesn't. So no matter how much care you take, if your battery is of doesn't last longer, then you can't help it, right? How charging cycle depends, not very clear, but I am assuming this is the uh, question that I just answered. I think it covers it, the charging cycle. The life of a battery is defined by number of charge or discharge cycles. Then we have can I get PPT? Okay, in order to get the PPT, you have to fill the feedback form. So once you fill the feedback form, you will get a link to this exact PPT. Then yeah, shorten the topic. Participant numbers are okay. Yeah. There is another question. Can I get a certificate? Yeah, you can get a certificate. You have to complete 4 classes for a certificate. Because you know, one class is nothing to be acknowledged in terms of certification. In order to learn something properly, you have to at least attend 4 classes. Uh, okay, so yeah, I'm guessing there is no other questions. Okay. If anyone have any question, okay, yeah, there is a one question just came. At what temperature we maintain cooling of battery? So as I was saying earlier, we want to have it below 40 degree. Okay. So for a car battery, the window of like 30 to 35, like 35 degree plus minus 5 degree is the like sweet spot. Okay, the Goldilocks zone. Okay, we don't want to move up above that. Okay, we can